All right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right back into it. We will be finishing this series eventually, but today we're going to be working on number 18. So, anytime you can, if you notice that every number in one of your equations is divisible by something. So, all of the numbers in that blue equation, that I'm calling it blue because I circled it in blue, they all divide by 2. They're all even. So I can divide everything by 2. If you can divide the whole equation by something, it makes it so that they're smaller numbers, and that's going to help you in the end. It seems like an unnecessary thing to do, and like technically speaking, it's unnecessary, but practically speaking, you're way more likely to get the correct answer if you're dealing with smaller numbers. So I highly recommend doing that. If we divide all of those by 2, it would just be negative x and then plus a 3y, and then that's equal to 3. All right, so then we have that. And by the way, we're supposed to be solving this using substitution. This is a worksheet on substitution. I forgot to put that in the title here. Well, I guess it'll be in the YouTube title, but on the title that I wrote in green cursive there, I didn't put that in substitution. It's supposed to be all of these questions are done by substitution. However, some of them are going to be easier to do with elimination. This one's kind of 50-50. They're all lined up, so it would be nice to do it with elimination probably, but we have to do it with substitution to get full credit or whatever. So the other equation, by the way, is going to be yellow. Yellow and blue make green. Didn't know this was also an art lesson. You're welcome. 2 for 2. Throw in some Spanish in there too. Se habla español. So blue and yellow, we need to put them together to make green. Green gets us the x's and the y's put together as well. That's kind of the vibe I'm going with here. But we're supposed to do substitution. Well, how do we do substitution? You gotta solve for one of the variables. There's 2 x's and there's 2 y's. So altogether, there's 4 different letters in 2 different equations we could solve for. It really doesn't matter which one we solve for that much because you'd have to do 2 steps to solve for any of them. So let's go for this one because this one's kind of nice. This one's the nicest one. If I minus 3y on both sides, boom, boom, get negative x is equal to 3 minus 3y. And then if I switch the signs, I would have x is equal to negative 3 plus 3y. Or you could say 3y minus 3. I kind of like that nicer, actually. I don't know, looks nicer. And then if that's what x is equal to, we can plug that in to the other equation. So then we go, okay, so negative 7, but x is equal to 3y minus 3. So instead of x, I put what x is equal to, right? So I'm plugging in what x is equal to, plus 8y equals negative 5. And then, boom, boom, so that's negative 21y plus 21 plus 8y equals negative 5. Now I'm just going to write everything in green because I'm combining blue and yellow here, so now everything's green. We're about to solve for y. So negative 21 plus 8 would be the opposite of 21 minus 8, which is going to be negative 13. So negative 13 y plus 21 equals negative 5. And then I want to subtract 21 from both sides. Boom, boom. Negative 13y is equal to negative 26. And then if I divide both sides by negative 13, I'll get 2. Oh, that was kind of nice. Then I plug it back in. So I'm going to plug in a 2 for y into my blue equation. So it's going to be 3 times 2 minus 3. And then that's going to combine and make green because the green is going to permeate the blue over here. I guess technically it should be like a lighter or like a teal or something, but I'm not getting super technical with this because this is actually not an art lesson. So x is going to be 3. Okay, but how do I know that's the answer? How do I know that x is 3 and y is 2? Other than, assuming I did all the math right, which I'm pretty sure I did. But what if you're doing this and you're like, maybe I keep solving it and I keep getting answers, but they're not the right answers. If you're running into that problem, here's how you can know for sure if you have the right answer. what you do is you plug it into the equation you didn't just use. Hold on. You didn't just use, there we go, math and English. I just used the blue equation to get x. So if I want to make sure that I have the right answer, then I want to go back to my yellow equation. So I want to go back to my yellow equation, and then I want to plug in my x and my y. If I plug in my x and my y, then I can be sure that I got the correct answer. So let's see. So negative 7 times 3 is negative 21. 8 times 2 is 16. Negative 21 plus 16 would be the opposite of 21 minus 16, which is negative 5. And that's what it's equal to on the right-hand side. So we know. And the really cool thing about checking it this way is if you're allowed to use a calculator, even if it's like a 4-function calculator, you can check it in the calculator very quickly. You would just type in the calculator negative 7 times 3 plus 8 times 2, hit equals, and if it equals negative 5, then good to go. You got the right answer. You can be sure that you got x and y equal to 3 and 2, and those are the correct answers, as opposed to, something else. So great way to check it, and it's really easy to do in a calculator. And that's it for 18. If you like this, then you might want to see some other stuff that's on my website. Go check it out, myersmathematics.com. I'm always trying to put stuff on there. Let me know if there's any videos that you'd like to see in the future, or any content on my website that you would want to see. Like if you want to see worked out solutions to certain problems, like word problems, but you don't want to pay for Chegg or anything like that, let me know in the comments if you want to see any kind of content that I don't have on either YouTube or my website, and I will make sure to slate that up next for my next upcoming projects. So anyways, have a good one. Catch you in the next video. Blessings, y'all.